Thank you very much for Marcus Evans, the organization, to invite me again and Ten Design to participate in your prestigious event. The project I'm going to talk today is in Hon Thom Island off Phu Quoc Island in Vietnam. It's an ongoing project. Again, this studio is a very recent studio, 1 year. This project, we are now in schematic design. So we started master plan, concept was approved, and now we are in schematic design. And I thought it was important to bring to this conference, given that the main theme of the conference, through several reasons. One of them is that this is actually it's a project in a remote island with challenges that right away with the construction, how to bring materials, how to get people to build the buildings, the infrastructures, all the elements of the master plan. So the concept design to documentation with geographical context challenges is one of the things I wanted to bring, not only geographical in terms of the topography and the nature of the site, but also in terms of being remote and what is really sustainable for us to design and to try to bring to this site and control the quality of the final product and so on. Cooperation between architect and industry leaders in modular and digital construction is fundamental. So it's something that I'll bring as we move along with the presentation, and also the implementation of standardization in sculptural buildings. Some of the challenges that we are still facing. Again, it's not the final product as we are in schematic design, but I will show where we are in this process. So first of all, where is Hon Thom Island? It's a Vietnamese island off the coast of Cambodia, actually. So it's in the south part of Phu Quoc Island. So it's really a island off an island. So there is no direct access so far, like conventional access. So far the most let's say the most used access to this island is through a cable car that was built by actually our client as well. This is the visual we have, aerial picture from the site, from the island, the Hon Thom Island, and it shows a demarcation of the project site as we show right now. At the moment, there are some developments within the island already ongoing. So at the moment, these areas that are built within our site are mainly related to the construction of every other sites within the island. So starting with the topographical analysis, and I mean, I'm not going to go too much on this. There's some slope that we have to deal with from 35 meters to all the way to the sea level. And also we had to do a quick study of slope analysis to see where it could be buildable or not. But in terms of buildability, I mean almost 100% of the site is friendly for that. In terms of going very briefly about the brief, in a very summarized way, the northern part, as we developed the master plan together with the client, was decided to locate the integrated resort zone that would host the iconic building, more sculptural building, hosting a hotel, integrated resort, like a casino, conventions, and so on. And mixed-use residential zone along the beach. So there's a part that is facing the mountain, a part that is facing the beach. Then low-rise residential moving southwards, and then a townhouse zone at what we call Townhouse Village in the most southern part. And this presentation, this is the illustrated master plan. This presentation will focus mainly in the Townhouse Village and the integrated resort, as I thought was the two most important, not the most important, most interesting projects to bring, most different within the same master plan, and to focus into different approaches and different stages of where we are in the development of schematic design. This is a little film that we usually do at the end of concept, just to illustrate or to show the overall project. So starting with the Townhouse village, I mean, located in the southern portion of the master plan. So this is the general view going around that promontory, but also generating that recreational marina. The challenges we had here is relatively uneven terrain, multiple typologies, requirement of variety, and also at the same time optimization of the sea view. So we had to combine these principles or these design principles so that we would create something that would be pleasant to live, pleasant to visit, and also worth for the client to consider as the development moved forward. I mean, we established a hierarchy of, let's say, a vehicular hierarchy and communication between circulation from also the pedestrian point of view. Just to highlight, the vehicular in this island is just limited to kind of electrical golf carts kind of vehicles. The blue, it shows the main, let's say, thoroughfare that would serve, do the supply and also bring people all the way to the marina and to the helipad, and communication between the main roads. And then in the yellow is more pedestrian seafront kind of footpath, and in red is really this kind of perpendicular to the sea. Connectivity in different levels, all the way going down from the main roads all the way to the pedestrian thoroughfare along the sea. So we have identified different typologies that were more into retail waterfront, retail inland, and purely residential as the group of elements of the architecture. So to establish like a hierarchy, but also a typology that we could work with in terms of what would happen in the ground floor, what would happen in the floors above, how high they could be, what kind of architectural expression they would have. So for this, I mean, our challenge was trying to keep a certain level of variety, but also standardize it to make it possible in a construction and a buildability in a remote place. So we believe that really this standardization and repetition and prefabrication again would be essential for this project. And we developed a certain level of number of combinations from the same size of plot, or approximately the same size of plot. Then in terms of what would be the height, the combination of different typologies. So we set an array, a matrix of buildings that address all these factors: the building height, the fact that if it's inland and purely residential, or if it has retail, or if it's in the seafront. So by establishing that, we generated different typologies and different conditions, but always with using a same type of modular architecture. And of course, we had different modules for corner units, and then from different, I mean, of course, for different stories, 3 stories, 4 stories, 5 stories, and different conditions all the way through. Again, trying to minimize the amount of different modules, but at the same time try to keep that variety that would bring the achieved vision of that character of that townhouse village. So this shows a combination of residential modules, different modules, very similar, but keeping that variety again. And then the same exercise was done for the retail townhouses around the plazas and pedestrian thoroughfares, and then the same exercise for the seafront townhouses with retail in the bottom. And with these same modules, we also had to work on the edge conditions facing the water, where there was a floating amphitheater, where there was purely the connectivity, the integration with the coastal connector and retail promenade, or just with a coastal connector, typical one, where there would be like a narrower condition between the building and the seafront itself. Also, the Grand Plaza and the marina, where it interfaces with the marina, so it was a different condition. And again, in a little hotel that is also within the typology. So this generated, of course, different buildings, but always starting from a certain type of module, a certain, let's say, standardized module with different typologies, yes, to create that diversity, but to make it again possible to do that design for manufacture and assembly, and potentially making this whole project more and more possible to be built, and to be built in a cost-effective way, not only in terms of bringing different materials to site and bringing it and all that in transformation on site, but also to two things: the logistical part of minimizing the amount of people on site to build it or to assemble it, and also to control the quality of the final product. So these things were very important for us to explore, to keep exploring. Again, we are in the not even at middle schematic design, so we are working still towards getting this to an optimal standard to be able to advance to construction. The integrated resort is a completely different case, where we also want to parameterize, we want to standardize to a certain extent. So it all started with a parameterization of the sculpture facade to be buildable in a cost-effective way. So we wanted to create an automated building documentation system for, again, manufacturing, assembly, and installation. Of course, in this one, because it's a sculptural element, we had different challenges. So we started with passing from converting our sketches and our vision into a free-form modeling using different tools, from computerized tools, to get that to a graphic or a visual expression that the client was happy with. We went through maybe 40 variations of this concept of the surface, of how the 2 or 3 surfaces would communicate with each other, would be seen from the approach from Thom Island, would be seen from the approach from the sea, and so forth. We finally got to a form and shape that the client was very happy with, and so from then we started parameterizing, trying to create a mathematical translation to this shape. We started testing 2 parabolic curves that would have the least variation from the approved shape, let's say, and that was. We found that at the end of the day was still a bit complex to standardize. The parabolic shapes are a little bit complex in terms of standardization and division in equal surfaces, subsurfaces of the main surface. So we then evolved to trying to get like after the parabolic. So we tried to get into an elliptical translation of those shapes, and the ellipse not only was equally successful in terms of the minimal deviation from what was the approved shape, but also gave us a better way of standardizing the division of the shapes, the surface shapes or sub-shapes, and consolidating in a more standardized type of glass panels, of outer surface that we could deal with as we progress in the design, in the schematic design, and so forth. So the shape at the end of the day is relatively simple, if you may. I mean, the blue lines, so they travel as pure ellipses. And the inner surfaces, they are pretty much extrusions from simple generated shapes based on circle and simple radiuses. So we could translate this more let's say irregular shape into something that is mathematical and regular. And from there we could start doing that division of the sub modules of the surface according to the control division widths of the panels that we were interested to make, and this already inputting some dimensions, internal dimensions that were convenient for us, that were related with the grid lines, structural grid lines, and so on. And with that, we could achieve an acceptable standardization where only in the edges, the top edges and the bottom edges of the surface, there would be different types of panels. So we could say maybe about 80 to 85% of the panels will be standardized panels, equal shaped panels, and so on, so that it could be, again, trying to get that off-site and off-site work, to maximize that off-site work, so that we could do a more simplified and purely assemble on-site work. So basically, what we wanted to bring to this process that we are right now, and we need to remember again, that this is an ongoing project at schematic design. This is a relatively young office here that we start, so I couldn't bring a total final product with examples of a built example. Hopefully in a couple of years I can bring that to you in this project, but right now what we wanted to show is that what we have been doing is a digital for manufacturing and assembly. Digital, yeah. So from the sketches to the design tools at concept, and then to design tools at design development. So using from the freeform sketches, 3D Max, Rhino, Grasshopper to try to get that standardization that I was mentioning just now with the surface and the subsurfaces in a modular and standard size, and then a live connection to ArchiCAD, so to BIM. So we really do a design for manufacturing and assembly as efficient as possible. This, of course, it's even for us, it's even more important for this specific project where there's a remote location. There's a reduced kind of construction time, and we want to maximize or optimize that construction time, and also the reduction of manpower needs and deployment of people to this site that is again an island of Vietnam continental territory. So this is just showing an example of us adjusting the formulas to standardize the surface of that shape, that sail of the hotel surface as much as we could, and then all this again from digital design to digital fabrication. We are looking into a number of things that we could do here, and we are designing in that with that aim. Use computer numerical control, prefabricated, pre-finished, and volumetric construction. We are working together with the industry as we speak to try to get not only the solution of design, but having the design developed already with the aim of building it in a as sustainable way as possible, and also controlling the quality and controlling, and that is fundamental to have these prefabricated panels, prefabricated elements, and trying to use, again, trying to make the construction faster, to control the quality and the finishes in a better way, to have to reduce the logistics as much as we can, to interfere with the site as less as we can, and to lessen again the deployment of workers to the site, and reduce the delivery of the project itself, the construction site. So we have another quick example here, a short film where we really mention this kind of PPVC approach and design, again for assembly and manufacturing and assembly in a way that we can really guarantee or the viability of this project. for today is what we could bring. I hope it's within the time that was given and it was clear enough for and interesting enough for the aim of this conference.